Yo, 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 this Coach Ray. That's lame. All right, first set of notes that I'm going over now is GCF, which stands for greatest common factor. Okay, greatest common factor. All right. So first one, I have 16x squared plus 8x. We already talked about it in my little introduction. We're trying to find two things that multiply together to give me that. All right, in greatest common factor, the best way I can describe it is it's kind of the opposite of distributive property. Okay, and the key word there is common, greatest common factor. What we're going to do is look at all the terms. In this case, there's two on example 1, and I'm going to see what do those two terms have in common. Specifically, I'm talking about multiplication. So when I look at 16 and 8, I see there's an 8 in both, or an 8 can go into each. So there's an 8 in common with both. They both have an x, yes? First one has 2x's, second one has 1x. Okay, so the most I can pull out is I can pull out an 8 and an x. It's going to look like this. I'm going to move my 8x out front, and now I'm going to kind of do the opposite of distributive property to figure out what would be left inside. Okay, so 8x, or 8 times 2 right here would give me that 16, and x times x would give me that x squared. Here we could look at it, if I pull an 8 and an x out, there was 2 left, and one of the x's was left. Okay, and distributive property, 8x times 2x is 16x squared, so I'm good. All right, this back one, I pulled out a whole 8x, yes? But it's not that there's nothing left there. There's a 1 left there because 8x times 1 would give me my 8x. Okay, so what I've successfully done is what we talked about a second ago. If I had a room that had an area of 16x squared plus 8x, the dimensions of that room would be 8x times 2x plus 1. Okay, that is what I have just successfully accomplished. And so my answer is this right here. Okay, so greatest common factor is finding something that all of the terms have in common and pulling that out. So doing the opposite of distributive property. Okay, next one, example 2. I'm looking at this. I see one's got a 7, one's got a 21, one's got a 14. Those all have a 7 in them, or a 7 can come out of all those. So I'm going to start doing that right now. Pull out the 7. They all have an x. Yes? Okay, so I can pull out an x. Okay, and actually, I want to go back to example 1 real quick. Check this out. I want to change this problem. If that back term said 8x cubed, then I would be able to pull out more than one x. Does everybody see that?
Yes.
I could pull out 2. I could pull out both of these x's, and I could pull out both of those x's, or at least 2 of those x's, so 1 would be left back here. So you want to pull out as much as possible. So anyway, back to our problem. I think I can only pull out 1 x in example 2, though, because there's only 1 x in the middle term, 1 x in the last term. Can I pull out a y? No. Why? No y in the first term. Everybody see that? Okay, so all I can pull out is a 7x. I'm going to just put my parentheses here and see what's left. If I pull out a 7 and an x, there's only 1 x left in that first term. 7x times x would be 7x squared. If I pull a 7 out of 21, or look at it like this, 7 times 3 is 21, opposite of distributive property. I pulled that x out, that's out front, but I do have these 2 y's left. Y squared is left in there. Are you okay with that? So if I multiplied those together, 7x times 3y squared would be 21xy squared. Okay, last one. 7 times 2 is 14. I pulled that x out. I left that y. I broke that big old ugly polynomial down into 2 pieces that multiply together. That is greatest common factor. All right.